Your tutor, Mr. Ngatia, and I want to actually look at something different, and whatever I want to look at is how do I really end up getting an equation of a tangent to the curve at a point in such a way that now in that case the value of x and y gets given. So for you to get a tangent to the curve, you are supposed first to actually follow the following procedure before you arrive at the final answer. So I'm going to use this example to be able to arrive at the final answer, and that is actually question 11. A curve is given by the equation y is equals to 5x cubed minus 7x squared plus 3x plus 2. And the question says find the gradient of the curve at x is 1, then the equation of the tangent to the curve at the point 1, 3. So you are supposed to actually do this. You have been given the equation as y is equals to, that is 5x cubed minus 7x squared plus 3x, then plus 2. So you've been told that you actually find the gradient of the curve at x is 1. So gradient first at x is equals to 1. So I'll come back here and be able to say that now for me to get the gradient at x is equals to 1, I'm supposed to say dy dx, or the gradient function is equals to what? So I can only get the gradient of this curve with this equation if I first have the dy dx, or the gradient function. So what do I do? This is how I'm supposed to get the gradient function, or the dy dx. I'm going to actually say y is equals to 5x cubed minus 7x squared plus 3x plus 2. Now, how do I get the dy dx? It is simple. I just come here and say this times this. That gives me 15. Then I reduce the power by 1. So I'm going to have x raised to 2. Okay. Then minus. I will say this times this. That is 14. Then I reduce by the power by 1. So I'm going to have 14x. Okay. Then I'll say plus. I assume there is 1 here. I'm going to say 1 times 3. That is 3. Then I reduce the power by 1. That becomes 0. So I actually drop it. If the number is constant, or the term is constant in that equation, it gets dropped. So it has no purpose in as far as our dy dx is concerned. So our dy dx is this. Now how do I get the gradient at a point when x is 1? I'm going to say 15x squared minus 14x plus 3. So what do? I'm going to actually say when x is 1, what is the gradient? Because this is our gradient function. So I'm going to replace. I'll say 15 into 1 squared minus 14 into 1 plus 3. So this gives me 15, then this gives me 14, then this gives me 3. So I'm going to have 1 plus 3. My final answer is 4. So at a point when x is 1, the gradient is 4. The gradient is 4. Correct. The gradient is 4. So the second part of the question says the equation of the tangent to the curve at the point this. The equation of the tangent, that means there's a tangent or a line that touches the curve at a particular point given as x1 and y3. So they want us to get the equation of that tangent, that line, that straight line that touches that curve. Let me just make a sketch here, not necessarily the sketch of this. But now look at this. I can have something like this. I have my Cartesian plane. In this case, I have my y-axis, I have my x-axis. I can make a curve, and in that case, let me say, for example, this is my curve. You see, so I can just label it y is equals to blah 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 blah, no problem. Then there's a tangent that touches the curve at 1, 3. That means when x is 1 and y is 3. So somewhere here. So let me just even estimate and say it is here. So let me say this is 3, the value of y, this is 1, the value of x, just an estimate. So I have to draw a tangent here. Look at that. So don't mind about my drawing, just understand the concept. So that one becomes a tangent. So they want us to get the tangent as far as its equation is concerned. At this point, x is 1 and y is 3. So this is our tangent. And obviously, the equation of the tangent must be in the form y is equals to mx plus c. Good. So how do I get the equation of this tangent touching the curve at x1, y3 in the form y is equals to mx plus c? Now, what you need to notice is that at this point, we've gotten the gradient of the curve at this point when x is 1 as 4. Remember, this was our gradient function. We were told to get the gradient at x is 1. So at point x is 1 on the curve, see, the gradient is actually 4, is what we got as our answer. So at x is 1 on the curve, the gradient is 4. And remember, the gradient of the curve and the gradient of the line or the tangent must be the same at the point of contact. So that means where they touch each other, they must have the same gradient. They must have the same change in y or the change in x. So that means at this point, the gradient of the curve at point x is 1 is 4. At this point, the gradient of the tangent is the same, which is actually 4. So at the point of contact between the curve and the tangent, the line touching the curve, there must be the same gradient. There must be the same change in y or the change in x. So that means for this tangent, the gradient is 4. And at this point, we have 1 as x and 3 as y. So I have the gradient and a pair of points. I can get the equation of the tangent very easily. What do I do? The equation must be in the form y is equals to mx plus c. So our y is 3. So we shall just say 3. Why am I doing this? I want us actually to get the value of c, the constant. So 3 is equals to m is the gradient, which is 4, times x is 1, then plus c. So 3 is equals to 4 plus c. I'll take this on this other side. So what am I going to have? 3 minus 4 is equals to the constant. So 3 minus 4 is equals to the constant. So that means the constant is equals to negative 1. The equation should be in the form y is equals to mx plus c. So y is equals to m, the gradient, it is 4. So I write 4, then x. The constant c is negative, so I'll say minus 1. That becomes the equation of the tangent. In that case, the gradient of the tangent and the gradient of the curve at that point must be the same. Great. Now, assuming I rephrase the question and then say, find the equation of the normal to the curve. The equation of the normal to the curve. What do I do? I've told you the gradient function of the curve is this. At point x is 1, what will be the gradient? We've actually done this and then gotten 4. So if this is the curve, at point x is 1. At point x is 1. The gradient is 4. If there's a tangent touching the curve at that point, it must have the same gradient. So how do I get the equation of this tangent? Y is equals to mx plus c, the form in which the equation of a straight line gets given. So I'll just replace to get the value of the constant. So I'll say y is equals to mx plus c. Y is the value of this part, and it's actually 3. It has 3, this is equals to 4, the gradient. 2, the gradient is the same. Then times 1, the value of x, then plus c. So you get the constant as negative 1. So you get the constant negative 1, the equation must be in the form y is equals to mx plus c. So it is y is equals to m, the gradient, which is 4, for the tangent, then x, then c is negative 1. So I would say minus 1. That one becomes my final answer as far as the equation of the tangent is concerned. Now, if the equation of the curve is given, and again we are told that we have to get the equation of a tangent, which is actually normal to the curve. I'll make a sketch. I'll do this, I'll do that, I'll do that. So I may have this one as my curve. Then I'm told there is actually a line which is normal, or a normal to the curve. You should note this. You must first draw a tangent. I've told you at this point we have 1, we have 3. So what is a normal to the curve? A normal to the curve is actually a straight line in the form y is equals to mx plus c. which makes 90 degrees with the tangent to the curve at the same point. You see, so that means this can be the normal. This normal line is actually a normal such a way that when that normal gets drawn, it makes or it forms 90 degrees with the tangent to the curve at the same point. Look at that. So you don't actually compare the perpendicularness of the normal and the curve. You compare the perpendicularness of the normal and the tangent drawn to the curve. So that means the normal and the tangent drawn to the curve must form 90 degrees. They must be perpendicular to each other. Now why do I even say like that? Because the gradient of the curve must be equal to the gradient of the tangent. You see, so that means the curve makes 90 degrees with the normal, or the normal makes 90 degrees with the tangent to the curve. You see, so in this case, if I get the gradient here to be 4, and as far as the gradient of the curve is 4, you see, that means the gradient of the line which is tangent to the curve is also 4. So I don't even need to bother so much about the curve. I'll just pick the normal, then the tangent. They are supposed to form 90 degrees. They are perpendicular to each other. The tangent has a gradient of 4. Then what is the gradient of the normal? We always say that m1 times m2 is equals to negative 1. So that means m1 can be the gradient of the tangent. So I'll say 4 times m2, the gradient of the normal, which is unknown. The answer must be negative 1. If I divide both sides by 4, I'm going to get m2 is equals to negative 1 over 4. So most students are actually familiar with this area will not even want to go through all this. They just take negative 1, then they actually put out of 4 to get the final answer. But they just take the gradient of the tangent is actually 4, they put over 1. Then what happens? They find the reciprocal. Then they get 1 over 4. Then they reduce a negative. It was positive. Very good. Now, if I've gotten the gradient as negative 1 over 4, the equation of this normal must be in the form y is equals to mx plus c. What is our y? We are saying at the same point. That means y is 3. Then m, the gradient, which is actually negative 1 over 4. So negative 1 over 4. Then times x. Our x is 1. So we shall say 1, then plus c. So you have 3 is equals to negative 1. Negative 1 times y is negative 1 over 4c. So you can say times 4, then times 4. So this and this will disappear. So 12 is equals to negative 1c. So if you divide by negative 1 divided by negative 1, that means c is equals to negative 12. So our c is negative 12. We shall come back here and write the equation. Y is equals to m. Our m is negative 1 over 4. Negative 1 over 4. Great. Then x. Then our c is negative 12. So minus 12. Good. Now if I'm done with that part, I can be able to simplify this further or even just leave it at that point. That one becomes my final answer. So that becomes this is the equation of the normal to the curve. You see. So when I pick the gradient of the normal, I multiply by the gradient of the curve. The answer must be negative 1 because they are actually perpendicular to each other. Let me see. So the gradient of the curve times the gradient of the normal, the answer must be negative 1. The gradient of the curve is 4. The gradient of the normal is negative 1 over 4. The answer is negative 1. Correct. Thank you so much.